Hello. So today we're going to go over the Final Exam Review, Unit 3, Number 1. And Number 1 states, a certain forest covers an area of 4,600 kilometers squared. Suppose that each year this area decreases by 9%. What will the area be after 11 years? So this is an exponential decrease, or 1 minus. So you take your original, $4,600, then 1 minus your percent, and then to time. So 4,600, 1 minus 0.09, or you could just subtract them. It said 11 years. And it decreases by 9% each year, so T is years. And you just plug that into your calculator. Round your answer to the nearest square kilometers. So that would be the ones position, and that 0 leaves it at a 0, so it's 1630. The next group solve the following. Okay, so you could solve either way. You could solve by elimination or substitution. If you're going to use elimination, I would make the y's drop out because the numbers are smaller. If I multiply the top by a -3 and the bottom by a +4, then here I'd have a +12 and here I'd have a -12, and my y's would drop out. So we have 15x plus 12y equals 0, and then -32x minus 12y equals 4 times 17, -68. Subtracting these two, I get a -17. X equals, this drops out, dividing by the -17, x equals 4. But you still need to go back and find y. So if I plug it in here, -8 times 4 minus 3y equals a -17. Add the 32, and get 15. So it's 4, -5. Number 3, g of x equals a -1 plus the log base 2x plus 2. Now the normal log, I'll draw it over here, has an asymptote here at 0, and it crosses at 1, and it goes like this. So moving right and left, in this case this is moving left 2, down 1. So the asymptote was at 0, it's moving left 2. Moving down 1 isn't going to affect it. So our asymptote is at -2. And then we were here at 1. We're moving left 2 and down 1, so it's here. And there's your graph. A mod places a bottle of water inside a cooler. As the water cools, the temperature in degrees Celsius is given by the following function, where T is the number of minutes since the bottle was placed in the cooler. And T was in minutes. Maud wants to drink the water when it reaches a temperature of 16 degrees Celsius. How many minutes would that be? Round answer to the 10th. We'll see if T is the temperature in Celsius, and it wants it 16, so we plug 16 in. Subtract the 8. Equals 14e to the negative 0.03 t. You need to get e by itself, so divide by the 14. That will reduce by 2. To get rid of e, you take the natural log, because they're inverses. Oh, that's good. These two cancel. Now, if you need an exact value, this would be it, but it said to round to the 10th. So plugging in negative 4/7 divided by negative 0.03. The 6 will round up to a 7. It said round to the nearest 10th. So do that. Number 5. Suppose that 2,700 is borrowed for 6 years at 8% per year, compounded continuously. Find the amount owed, assuming no payments are made until the end. So we want to find the total amount. Starting amount, 2,700 E to the 0.08 T. The formula is A equals P E to the RT. So we plug it in. So what were we given? Continuous. Oh, 6 years. There it is. It's right up here. So it's for 6 years, so we plug 6 in for t. $2,700. E is where the natural log is. 0.08 times 6. And since it's money, you round dollars and cents usually. Round to the nearest cent. Number 6. Solve using substitution. Well, substitution is the easiest because this is already solved for y, so we take this and we plug it in for y. Negative 2x plus 5 times 3x minus 19 equals a negative 30. Distribute. That is a 19. Five times 19 is 95, and it will be negative. Combining these two, 13x, adding this to the other side, gets us 65. X is 5. And then we can plug it back in here. (15 minus 19 is a negative 4. For each function, state whether it's one-to-one. For one-to-one, use the horizontal line test. And this would pass, so yes, it is one-to-one. This would pass, it's one-to-one. This one would not pass. Notice on the x-axis there's 2, so this is no. This one is yes. The parabola is no. This one is fine. Number 8. The amount of money invested in a certain account increases according to the following function. Y equals y sub 0 e to the 0.025t. T is in years. After how many years will the initial amount double? Okay, so even though they didn't give us anything, you can still test that. If we start with 10, and we just need to double it. So you can put any amount here as long as when you're done it's double, so in this case 20. So whatever you put here, just double it. Doesn't matter what it is, we'll all end up with the same value. Divide by the 10 and get 2 equals e to the 0.025t. Take the natural log to get rid of e. And then divide by the decimal. If you need the actual value, it would be this. This one says, do not round until the end and round to the 10th. Natural log of 2 divided by 0.025. 27.7. Number 9. Chang deposited $4,000 into an account with 5.7% interest rate. .7% compounded semi-annually. Assuming that no withdrawals were made, how much will he have in the account after 7 years? I think, I'm not sure. I have 3 different classes that use 3 different variables for the N, M, or C. But it's the number of compoundings. A is the amount at the end. We're starting with 4,000. 1 plus R is your rate as a decimal, 0.057 divided by semi-annually is 2 times. And then 2 times 7 years. And just plug it in your calculator. $5,928.16 is how much will be there at the end. And 10. A mass of a substance which follows a continuous exponential growth. So continuous is PERT. Is being studied in a lab. A sample increases continuously at a relative rate of 6%, so R is 6%. Per day. Find the mass of the sample after 5 days. If there is 348 to start. Just plug that into your calculator. 348 E 0.06 times 5. Round to the nearest tenth. 469.8. I think it was, grams. Number 11. Use the properties of logarithms to expand. So the log, remember when there's no base, it's base 10. Y to the 7th over Z. So Y is on top, log Y to the 7th. Z is on the bottom, so it's minus log Z. And then remember, your exponents come down in front. Number 12. Below is a graph of e to the x. Transform it. Okay. Give the range and the domain. This flip on x-axis, and this moves left 2. So it was up here at 1 going up. It's going to flip. So then it's here. So it was here. This one going up. It's got to flip. It's going to flip down. So it's here. And then it's going to move left 2. So it's here. The asymptote was here. You can see the asymptote on the graph. And we didn't move up or down, so it is still there at 0. So the domain is all real numbers. And the range, all these negative values until I get to 0. So it's negative infinity to 0. 0 will be a parenthesis. It's going to approach it. It's not going to hit the x-axis. Number 13. The number of bacteria in a certain population increases according to a continuous exponential growth. PERT. With a growth rate of 9.7%, how many hours, so we're looking for time, does it take for the size in the sample to double? Okay, just like when we doubled with money, whatever this is, this has to double. Take the natural log of both sides because that drops. And divide by the decimal. Plug it into your calculator. And round to the nearest hundredth. That's 2 decimal places, so the 4 will move up to a 5, 7.15. And time was in, I think it was hours. Yeah, hours. $15. I don't know why I said 15. This one was 13. This one's 14. Log base 2 x minus 2 equals 2 minus log base 2 x minus 5. Okay, so the first thing we need to do is bring these logs on the same side so we can combine them. You could just set the functions equal if we didn't have the 2 there, but since that 2 is there, we need to move the log over. Okay. Then when you're adding, they become a multiplication. So it's log base 2 x minus 2 times x minus 5. Then we can rewrite them, loop around or backwards C. 2 squared equals, and then I'll just write it first. You could FOIL this right now, but 2 squared is 4. Foiling, we have x squared minus 7x plus 10. Subtract the 4. X squared minus 7x plus 6. It will factor. 2 numbers when you multiply, you get 6. That when you add, you get negative 7 is negative 1 and negative 6. Setting them equal to 0. we get 1 and 6. Now you need to check your answers because remember you can't take the log of 0 or a negative number. If we plug 1 in here, 1 minus 2 is negative. Well, we can't have that. We plug 6 in, 6 minus 2 is positive, it's a 4. And plugging 6 minus 5 is 1. So this answer will work. But you do have to check because remember you can't take the log of 0 or a negative number. Log 7x equals a negative 2. Simplify your answer as much as possible. Okay, if we rewrite it, 7 to the negative 2 equals x, which would be 1 over 7 squared, which would be 1 over 49. This is one where they do not want the decimal, they want the fraction. (14x plus 9 equals 9 8x). Now normally on these ones you try and get the same base, but 9 and 14 cannot be. So we take the natural log. That way we can bring the exponents down. Distributing, we have x natural log of 14 plus 9 natural log of 14. And here we have 8x natural log of 9. I need to get the x's on the same side, so I'm going to subtract this one over. Because then I can factor the x out. And then divide by this. Write the exact answer using either base 10 or base e. I used base e. You could have had log of base 10. But that would be it. Rewrite as an exponential function. Just rewrite it. 8 to the first equals 8. Three to the negative 4 equals 1 over 81. Rewrite as logarithmic equation. Okay. Start with the base and loop around. Log base 3 of 1 over 81 equals a negative 4. Graph it. We know it's decreasing because this is less than 1. It's crossing at 1. It's there. And asymptote at 0. That's it. Below is the entire graph of the function. Find the inverse. So the first point is -2, 4. And then this point is -5. Here, 0. And the last point is -6, -8. So here's the original. Now the inverse, this is F. F inverse, you just flip them. 4, -2, 0, -5, -8, -6. So then if we graph it, 4, -2. 1, 2, 3, 4, -2. It's here. And then 0, -5. 3, 4, 5. It's here. And then -8, -6. 1, 2, 3, 4, 5, 6. Here. So the pink is the inverse. Notice they flip on this. This is the y equals x line. Oh, that can't read that. So it flips on that line. But all you have to do is take the points and then reverse them. Because the inverse, remember when we're finding it, we switch the x and the y. Number 20. Graph 3 to the x minus 2. Okay. Exponential similar to this one, only it's increasing. So the original graph crosses at 1 and it goes like this because this is greater than 1. This one was less than 1, so it decreased. This is greater, it increases. So this is the original. The -2 moves it down 2. Because it's moving, the asymptote is also going to move down 2. So the asymptote will be here at y equals -2. And then we were at 1. We're moving down 2, so we're here. And there's your graph. And then they ask for the domain and range. All real numbers for x. The range. There's no values until we hit -2. -2. to infinity. This is a parenthesis because we're approaching the asymptote but not crossing it, and it is at -2. These ones, so we have log base 9 of 8 minus log base 9 of 11. When you're subtracting, you divide, so it'll be 8 over 11. Log base 2 of 5 plus log base 2 of something gives us log base 2 of 45. Well, when you are adding, you multiply, so 5 times what is going to give us 45? And that will be 9. This one, it has a number in front. Well, the only way to get a number in front is when you have an exponent, you can pull it in front. So we need to rewrite this. And notice this is 3, our base. Well, 27 can be written as 3 cubed. 3 times 3 is 9, times 3 is 27. And then that 3 could be brought in front. So it's a 3. Mr. and Mrs. Taylor hope to send their son to college for 14 years. Oh, in 14 years. How much money should they invest now at an interest rate of 9.5%, 9.5% per year, compounded continuously, in order to have $9,500? Compounded continuously is PERT. We want 9,500 at the end. We want to know how much we need now at 0.095 for 14 years. Do not round, and then at the end, round to the nearest cent. We're looking for P. You could multiply this first. .095 times 14 is 1.33. We're getting P by itself, so we're going to divide by E. And you just plug that into your calculator. 9,500 divided by E to the 1.33. 2512.53. So $2,512. Let's squeeze it. 23. 5 log 6. 5 log base 6 of y minus 1/4 log base 6 of z plus 6 log base 6 of x. Write the expression as a single log. Well, before you can combine them, you have to move all these up into the exponent. So log base 6 y to the 5th minus log base 6 z to the 1/4 plus log base 6 x to the 6th. Then the ones that have positive in front of them go on top, negatives on the bottom. Log base 6 y to the 5th, because this is positive. Z goes in the bottom because it's negative. And this one's on top because it's positive. And that's your final answer. The one-to-one functions g and h are defined as follows. Okay. G equals -4, 9, 0, -2, 6, 3, and 9, 4. And so let's write G inverse. Just flip them. 9, -4, -2, 0, 3, 6, 4, 9. So if this is G, this is G inverse. Just switch your X and Y's. Want G inverse of 9. So when X is 9, go to G inverse. Our answer is a -4. Because G inverse equals 1. So go to your inverse and write it. The other one, first thing it asks for is to find the inverse. Remember, the inverse has 4 steps. First, change this to a y. Switch your X and Y. Solve for y, so add the 9. And divide by 2. And change your y to an inverse. Now, when you're taking the composition of an inverse, it's just going to give you the value back. But if you wanted to check it, you can go h of h inverse of 5. In this case, a -5. So if we find -5, plugging it in here, we get -5 plus 9 over 2. Which is 4/2 or 2. So this is 2. H of 2, going up here, is 2 times 2 minus 9, which is -5. So when you have a composition and you plug it into one and then plug it into the other, it gives the original back. So you could have just said -5. Evaluate each. Log base 5 1/5. Now what you could do is put an x here and rewrite it. If we rewrite it, 5 to the x equals 1/5. We can get the bases the same by bringing that 5 up. When the bases are the same, the exponents are equal. X equals a -1. B, log base 2 of 32 equals x. Rewrite it 2 to the x equals 32. Get the same base. 2 to the x equals 2 times 2 is 4 times 2 is 8, 16, 32, so it's 5. X equals 5. For each pair of functions below, determine whether f and g are inverses of each other. Okay, to be an inverse of each other, when you plug one into the other, you need to get x back. So if we have the first one, f of x equals x minus 2, and g of x equals x plus 2. So we want f of g of x. So we're taking this one and plugging it in here. We get x plus 2 minus 2, which is x. If we go the other way, plugging this one in here, we get x minus 2 plus 2, which is x. Since both of those are x's, they are inverses. The other two are these two. Finding f of g of x. So we're plugging this one in here. 1 over 3 times a negative 1 over 3x. The 3's will cancel. You have this, and then you flip and multiply, and this equals negative x. G of f of x. We're plugging this one in here. It's a negative 1 over 3 times 1 over 3x. The 3's cancel. Negative 1 over x. Flip the bottom and multiply, and you get a negative x. Because I didn't get positive, not inverses. Twenty-seven. 81 equals 27 negative x plus 5. Both of these can be written as 3 to a power. 3 times 3 is 9, 27, 81, yeah. 3 to the 4th, and this is 3 cubed. If you get the same base, you can set the exponents equal, and then just solve. Distribute. Negative 3x plus 15. Subtract the 15. Negative 11. And then divide by the negative 3. X is 11/3. 28, also solve for x. Log base 5, negative 3x plus 10 equals 1. Rewriting it, 5 to the first, do your loop, equals a negative 3x plus 10. Subtract the 10. I have negative 5 equals a negative 3x and divide by negative 3. 5/3 equals x. If we check it to make sure it's not a negative, because the x is where the log is, we get a positive 5, so it's fine. 4 plus ln x minus 3 equals 5. Get the natural log by itself. And then take e of both sides because they're inverses. X minus 3 equals e to the first. Add the 3. X equals e plus 3. The 1 doesn't have to show because it's a 1. Oh, this one they wanted us to plug in the calculator. So e to the first plus 3. Round to the 100th. 5.72. Last one, number 30. Rewrite each equation as requested. Rewrite as a logarithm. E to the x equals 6. So rather than memorize the formula, just take the natural log of both sides because they cancel. X equals the natural log of 6. And the same thing when you have the natural log. Natural log of 4 equals y. To write it in exponential, just take e of both sides. 4 equals e to the y. I think that's it. Yep, 30 of 30.